So I just came across this fascinating architecture called Kimi-Linear, and it claims to outperform traditional attention methods.
Really? I mean, attention mechanisms have been a big deal in AI. What makes Kimi-Linear stand out?
It's this hybrid linear attention architecture. They introduced something called Kimi Delta Attention, or KDA, which optimizes memory usage.
Interesting. So how does it actually improve performance, especially for long sequences?
Well, it reduces the need for large key-value caches by up to 75% and boosts decoding speed significantly, like up to 6 times faster.
Wait, seriously. That's a huge leap. But are there any trade-offs involved with this speed?
Good question. They claim performance remains superior across various tasks, but I'm curious about how that holds up under different conditions.
True, I'd want to see if it's still effective in diverse, real-world applications. What about reinforcement learning?
Exactly. Kimi-Linear also performs well in RL scenarios, which is impressive given how complex those can be.
I wonder if that means it could reduce training times for RL models significantly. That could be a game changer.
Right, they've trained it with over 5.7 trillion tokens, but I'm skeptical about how scalable this is in practice.
Scalability is key. If it's not easily deployable or doesn't scale well, then those gains might not translate.
Exactly, and it's open source too, which is great for accessibility, but I worry about the community support.
Community support can really make or break these projects. Have they released any model checkpoints?
Yes, they have two versions on Hugging Face. One's a base model and the other's for instruction tuning.
That's cool. Using Hugging Face makes it easier for developers. But how does the model handle different contexts?
It's designed for both long and short contexts. I think it's fascinating how adaptable it claims to be.
Adaptability is crucial. But let's talk about actual usage. How user-friendly is the implementation?
They recommend Python 3.1 or newer along with specific libraries, but I wonder how intuitive the API is for newcomers.
That's important. If it's too complicated, developers might shy away from adopting it despite its performance.
Exactly, and they mention deployment using something called VLLM for API endpoints. What do you think about that?
It sounds promising, but I'd want to know how it compares to other deployment methods in terms of performance and ease.
Definitely, and while it's exciting, I think we need to see more evidence on its real-world effectiveness.
Absolutely. Let's not forget about potential biases or limitations in the dataset used for training.
Right, biases in training data can limit a model's generalization. That's something worth considering.
And with such a large model size, efficiency becomes critical. How do they ensure it doesn't get too resource heavy?
They claim to optimize memory use and throughput, but I'd love to see real-world benchmarks supporting that.
That would really help. If it can prove effective without massive resource demands, it could really change the landscape.
Totally, and I think it's also about how easily it can integrate with existing systems.
Integration is key. If it's clunky, developers won't stick around to explore its potential.
Exactly, so when you think about all these factors, what do you find most compelling about Kimi-Linear?
I'm intrigued by its potential to handle long sequences efficiently. That could really help in various applications.
Right, but I'd be cautious about overhyping its capabilities without solid evidence to back it up.
Definitely. It's a balancing act between excitement for innovation and the need for critical evaluation.
So true, and I think it'll be interesting to see how the community reacts and what they do with Kimi-Linear.
Absolutely. The next year or so will show us if Kimi-Linear lives up to the hype or falls short.
Totally, it's like we're on the brink of something exciting, and I can't wait to see how it unfolds.
Same here, but let's keep an eye on those benchmarks and user experiences as they come in.
For sure, and it'll be interesting to discuss how these developments might influence the future of AI architecture.
Absolutely. It's such a dynamic field, and innovations like Kimi-Linear could shape the direction we're headed.
Right, so as we wrap up, what are you thinking might be the biggest takeaway from our discussion?
I think it's the importance of balancing excitement for new technology with critical thinking about its implications.
Well said, it's such a complex landscape, and staying informed will be key for everyone involved.
Definitely. And I hope our listeners feel inspired to dive deeper into Kimi-Linear and its potential.
Absolutely, let's keep the conversation going as new insights emerge.